Suppose the function of x is equal to 1/2 ln x and the g of x, the second function, is negative 1/5 ln x. For each x in the interval from 0 to 1, consider the rectangle formed in the following manner. Its right side is the line segment connecting the points x, the function of x, the g of x. Its left side lies along the y-axis. Which value of x in the interval is from 0 to 1 results in the rectangle of the largest area. So what we're first going to do, I'm going to draw an xy plane so that we can model this situation described. Okay, so we know that in the xy plane, this is the x-axis and this is the y-axis. I'm going to make it bigger, the interval. I'm marking this point because I know that the ln's will meet at this point, because the ln of 1, when x is equal to 1, the ln's will be 0. So the functions both will be 0. So they will meet exactly at this point. But one of them will rise, as you can see here, because of the positive slope, and the second one will fall because of the negative slope. Right? So we can have the g of x first. So for the first function, we can draw a line like this. It looks something like that. And for the second function, we can use another color. Something like this. Okay? So now, basically, here's what's going on. So as we finish drawing these two functions, we have to understand how we're going to build the rectangle. Right? So obviously we're going to start from the origin. That's the point where there's a 0, 0, basically the coordinates there. Right? So we know that the left side lies along the y-axis, right? So we know that one side of the rectangle is going to be here with something like this. And that fits the description, right? Because it says that the left side lies along the y-axis and the right side connects, the right line segment connecting the points the x, fx, right? So this will be x, g of x here on the top, because g of x is the line falling. And this will be x, f of x, because the slope here is in positive. Okay, and that fits the description because it says the right side of the rectangle is the one that connects the points on these respective functions. Okay, and the left side lies along the y-axis. Now we're trying to find the value of x. Basically, we're trying to find the greatest, the side here, the x side here, that will result in the largest area of this rectangle. So in order to find the largest area, we have to derive the area. We have to find the area of this rectangle as a function of x, because that will allow us to take the derivative and then find the x value when we set that derivative to 0. Okay, so the first thing that we're going to do, we have to derive the area formula. How do we do that? We have to multiply the x, of course, because we know the area of the rectangle is the width multiplied by the length. We have to derive the length. How do we express the length in terms of x? Notice that the length can be found by subtracting this vertex point from that vertex point. Right? So we know that the width is going to be x. And the length is going to be subtracting fx from gx. And why are we subtracting? We're subtracting and not adding because this part of the rectangle side is below the x-axis. Right? When it's below the x-axis, we know that this part will be negative, and we're interested in the absolute value of this remainder of this side. Right? So we have to subtract so that when we negate, subtracting will make it positive. Right? So gx minus f of x. How does that translate to in terms of x? The gx is equal to negative 1/5 ln x, and the fx is going to be what? 1/2 ln x. right? So 1/2 ln x. And you might say, but wait a second, didn't you just say it's going to be negative? Why is it a positive coefficient 1/2 here? Well, keep in mind that ln x at this point, right, ln x for x values between 0 and 1 will be negative, right? So when you subtract the negative, because ln of this point of this x value precisely, which is less than 1, will be negative. So when you subtract the negative, what happens? It will become positive, right? Because there are two negatives. So this is going to be, and let's simplify this, negative 1/5 minus 1/2, and this thing multiplies ln x, right? So simplifying this now, we know that we're going to have, using the LCD technique, minus 2 minus 5 on the top, which is going to be minus 7 over, the LCD is going to be 10, right? 2 times 5 is 10, so negative 7/10 ln x. Okay, so now that we found negative 7/10 ln x, we can find the area, right? So the area formula is going to be what? As a function of x. The width times the length, right? So it's going to be x times negative 7/10 ln x. So that means it's going to be simply negative 7/10 x times ln x. Good. So now we find the area, and now we can just simply differentiate that, and we're going to then find the x value that yields us the maximum. Right? So we're using the product rule. First, we're going to differentiate the x. The derivative of the x is simply 1, right? So it's going to be negative 7/10 multiplied by 1 times ln x, right? Because the ln x is the second function which we do not touch using the product rule. And then plus, of course, negative 7/10x, which is not touched, and now we differentiate ln x, which is going to be 1 over x, right? So that's going to be what? Simplifying that, the area formula becomes negative 7/10 ln x minus 7/10, right? Because we know that algebraically the x's cancel out because one of them is in the denominator. Okay, so good. So now we set this, sorry, that's the derivative. So now we're going to set this to 0 because that's the derivative that we just found. So negative 7/10 ln x minus 7/10. So look what happens. We can add 7/10 on both sides, and that way we're going to get 7/10 is equal to negative 7/10 ln x. Dividing both sides by negative 7/10 will give us negative 1 is equal to ln x. So now how do you find the x? Well, you're going to use the e now. If you make these exponents to the e, look what's going to happen. E to the negative 1 is going to be e to the ln x, and as you know, e to the ln x is equal to x, right? So thus x is equal to the e to the negative 1. Perfect. So e to the negative 1 seems to be the value that will give us the maximum. So we're going to check this x value into the area formula. The area formula was this one, right? That was the area formula. So let's check it inside the area and see what we get. So area as a function of e to the negative 1 is going to be negative 7/10 e to the negative 1 times ln of e to the negative 1. Okay? So now what is that going to give us? Let's check using the calculator. So e to the negative 1 times e to the negative 1, ln of that, and then times 7/10 negated, right? So it's going to give us something like 0.2575. You can check the points right above the e to the negative 1 and right below e to the negative 1. So let's check. E to the negative 1 point was about 0.3679. So what we can do, we can check a as a function of 0.36, and also A, the area, as a function of the x value of 0.37, right? So these are the immediately surrounding values of this value, right? This value is between them. 0.37 is greater than 0.36. 0.36 is smaller, is less than 0.3679. Right? So basically this is for your own practice. Check these areas and you will know that these areas that you get from these values, you're going to plug it in there, you're going to see that the area you get as a result of these values will be smaller than 0.2575. This is for your own practice. You can check yourself that way. We already checked the endpoints, that this is indeed the largest area possible with this x value of e to the negative 1. So I hope this was fun and helpful. Thanks for watching and see you in the next video.